Hello, my name is Paweł Firek. It's a great opportunity to be here among all of you scientists. Not from science, I'm from business. So once again, thank you, Professor, for invitation. And I would like to start from a short story actually, because Simon Sinek write a book, and it all starts with why. This is the main question. So we are talking today about Quality 4.0, about digitalization. So why to do it? The first thing. So I would like to start with a short story. It's an example of one of our implementations. One of our clients a few years ago it is a furniture, one of the biggest furniture manufacturer in Poland, and they were producing tables. And in the process of producing this table, they were coating legs of the table with paint automatically, and they were measuring before and after coating the paint on the leg, and writing down the measurements. And the measurements was in the range, but there was some problems always with quality. So they tried to put quality control cards as a first step, but it shows that there is some issues with that because the process was not stable. So as a second step, they automated it. But after the automatization, after bringing it to the MES system and the quality model, it found out that it wasn't so bad. So everyone was asking what is going on, what was happening. So as an external consultant, we tried to ask operators without letting know managers what was happening. So the answers was that they've got special notebooks, which they check the numbers and write down the numbers to the formulas. So it shows that this human factor in this kind of situation, it could be crucial, because it could, without some kind of automation system, some kind of digitalization, it could bring us completely failure information about the process. Okay, so I would like to talk today about digital transformation in inline quality control versus offline quality. So inline quality control. So I mean next to the production lines on the shop floor, exactly. Versus offline, when we take the sample and take it to some laboratory, do some test, and put the examination into some soft paper or to some system. So first, I would like to introduce my company. I'm from InFactory. It's a shortcut for Improvement Factory, and we try to be a partner of companies in digital transformation, as I mentioned. I'm Paweł Firek. I'm Business Development Manager responsible for CE market. And we as Improvement Factory, as InFactory, we are also Aviva MES Competence Center, and we have more than 25 years experience in realization and in dealing with the projects with automatization and mainly digitalization. For example, like MES systems, which part of MES systems could be quality. Also, we are operating not only in Poland but also in CE region, and from this year also we moved to the Western markets. And we operate as Astor Group, and there was few presentations before, there was mentioned that there is a hub for industry. Astor Group is in hub for industry in Krakow, and actually they've got two showrooms in Krakow. First in Smoleńsk 29th Street, and second in Wrobela 5th Street, which you can see, which you can examine how the Industry 4.0 looks like. If you'd like to check it, feel welcome. It's free. You can sign up and check it how it looks like. Okay. So digit in general. There are three in English. In Polish, it's easier because it's cyfryzacja, let's say. So it's one word. It could be one word, yes. But in English, we've got three definitions. Could be three definitions. First, it's digitization. So it's moving from paper to some systems, for example, Excel sheets or something else. Second is digitalization. It's similar to digitation, but it's like moving online. So moving from this Excel or moving from these documents, which could be written down on a computer, for example, to a cloud. Yes, and then it's full process, let's say, digital transformation, so adopting overall transformation in all aspects. So this is the definition. And from when we are talking about quality 4.0, it's like from quality as a process, like you can see, has undergone few or several transformation over the few past decades. And so from the regular inspection on the paper to total quality management systems, which were mentioned today also. And now, when we are in this fourth industrial revolution, it has become the part of routine of some organizations and people. And in my opinion, it's very important to maybe even not to digitalize, but to start to thinking about it, because it will help and support organization in the future. So in the past, as you can see, it was mostly like doing some checkings and put it numbers on the paper forms. So as you can see, it was some kind of forms, was gathering data, informations, then it was typed as a next step to a computer to generate some analysis, some reports, and to make the decision. Today also we can find in some plants, some manufacturing factories, this kind of situation. It's not good, but how it could look like and how it should look like in the future, as you can see here, when we are talking about quality 4.0, it's not only like putting a sensor or make something works automatically. It's more like combining a lot of information among the manufacturing companies in one efficient system, and to exchange the information between, let's say, the module of the system in good way. So, like you can see here, when we are talking about, for example, quality specification management, so it starts with generating work order, and starting with generating work order. And work order generates sample plans automatically, and the software could maintain alignment with execution process status and also resources. So it's all combined into one efficient system. And next, like you can see, based on the current work order status, the software could automatically, for example, sample quality data from connected equipment, or notify operations and enforce sample procedures. So here I would like to show you a few examples of like real data implementations. So this is an example of door and window factory, which digitalize in every aspect, from the beginning of the process, from the sales, from the information of the customers to the end of the process, to the production. So this is the example of the process. At the end, they've got not only, let's say, one system, but few modules which realize special functionalities. And here I would like to focus on few functionalities. It's like OE and SPC, sometimes it comes together as one module. It could be, for example, OE system extended, because it's not the topic today, extended with SPC. So in this module, new samples could be generated automatically with production progress, and also results registration could be combined with online documentation side by side. So it's make whole the process more easier for operators, and sometimes cancel this human factor when something could go wrong. It's examples of reports, how some system could generate, and another example is also transition from paper to digital. So from paper forms, mapping a process, and then as end result, it's an automatic system which can collect data through customizable forms and automatically send this information to server and generate reports at a glance. And also, like you can see, it's a sample of the reports. Additional information could be added to the report, not only numbers, but also, for example, so photo documentations or some additional comments and information. And also another example in this implementation was quality logs and reworks. So monitoring and support of these defective processes, because in some processes could be more important than others. So this company decided to put this kind of system on these more important processes and monitor and support defective of this kind of processes. So in automatic way, marking of defective orders and ability to trace its history. And at the end, it increased level of high quality products. And here is example from automotive industry, and they've got challenges like they've got 120 measurements per product and 9 change orders. So at the end, it was more than 1,000 measurements points per shift in this particular company. So they've got, at the beginning, they've got some automated system, but it wasn't efficient enough. They switched to the papers, and it gave them some increase in time registering, but they noticed that when the one piece of paper were finished, So it generates and complicate the process to bring another part of paper and to fill it well to cover all the needs. So at the end they end up with our support and we together figure it out in one fast and reliable system, which involves the operator as little as possible in the application, and after taking one measurement and entering the value, as you can see here, the system automatically moves to the next measurement, so it fastens up whole the process a lot. I've got some time here, so I will exchange for the movie. I will show. Okay. Yes. Oh, okay.
In this demonstration, we will learn how Aviva helps you to ensure quality and compliance within your operations. Now, let's look at a use case about ensuring quality and compliance. In this demo, a possible quality issue is recognized and raised to a quality department. The quality manager analyzes it and then requests action from the line supervisor. Then an operator executes the new requirements, and the quality manager can see how the quality issue gets resolved. In this demo, we are going to look at how Aviva MES is used to solve a quality compliance challenge. Elsa is the quality manager and receives a notice of quality concern from the customer feedback and compliance team. She is able to track the batches based on the data she received. She uses filters on the right-hand side by providing the finished good storage, product, and dates. She then checks the associated batch records for batch ending 247. This dashboard is an example that demonstrates how Aviva MES tracks batches or lots. By navigating backwards, Elsa can find all related batches. Here she can easily see how the batches are correlated, and based on the information she suspects now, there may be an issue in the reactor process for this product. Elsa decides to review the quality samples to verify her concern. She navigates to the MES SPC chart and selects the product and production dates of the linked batch. From the genealogy dashboard, she was able to see at which dates the original batch of SF01 was produced. Aviva MES SPC chart supports various different charting types. Here we are looking at a standard export chart. Elsa hides the rates chart, and now she can see that the temperature check was constantly below limits, and as it was marked as a non-critical sample, the results were simply ignored. Elsa requests Mark, the line supervisor, to create a new sample for the reactor. This will keep the temperature in control. Mark should create a startup check that ensures that operators checks temperature set points and associated sensors before starting. This will prevent the temperature from deviating from its limits that were previously thought as non-critical and now may be critical for this type of product. Now Mark is adding characteristics to the newly created startup check. He then adds a target value, a lower and upper limit for each characteristic within the sample. When Mark is done, he saves the new sample request. Later, Jill, the operator, starts to produce SF01 at the reactor and receives a new startup sample request, which was created by Mark. This time, MES assures that new guidelines and machine setups are followed to keep the temperature within control limits. Now let's get back to Elsa, the quality manager. She can now go back to monitor the finished samples for product SF01 and recognize how the new SPC values for reactor temperatures have changed to more optimal conditions. This is the effect after applying new startup checks for the concern that came from the customer feedback and compliance team.
Okay, so how you could see there, so the modern systems which support production, it's not only one system which focus only on quality, for example, but usually it's a combination of few systems which exchange data between themselves. So at the end, business value, why to do it, why to digitalize? As you can see, reduced cost of quality, standardization is very important, and performance of quality check procedures, improve yields and minimize quality giveaways, and support manufacturers to increase the efficiency in capturing the critical quality information. And alignment with production activities and in response to shop floor events. So as the Dr. Peter Drucker said, if you can't measure it, you can't manage it.